Thanks, guys. No need from my side. It's a workshop, meaning the content is about Marco and the contribution about you. So just welcome. The idea was to get in touch base, be active in the last, let's say, month of the project. We will have another opportunity to meet in a sort of workshop during the meet attraction in Spain in March. We already had one in Slovenia due to the presidency. So I think we are in a good action mode, and I give back. Just reminding you, Marco, I think to save time and to concentrate on really the main issues, the meat market issues, you should skip or not even tackle. We don't need half of the slides about market. A lot of our guys know even much better. I give back to, let's say, Marco first, and the questions for maybe a quick circular. And I forgot, whenever somebody is taking the floor, as we are now 37 people, which is a really good resonance, maybe you can introduce quickly. So it was me, Karstmeier from the UECBV Secretariat in Brussels. Having a feeling a bit we are coming back to normality with some physical meetings, but that's just to have a quick introduction. Thanks for that. Handing over back to mainly Marco.
Yes, thanks a lot. My name is Marco Della Feld. I'm a project manager in UCBB, and in particular, I have mainly focused on the the European project of UCBB, and one of these is Water2REturn. The project, after around 53 months of development, is going to end. And we have developed and tested a demonstrator linked with the slaughterhouse for the wastewater treatment with an approach of circular economy to obtain mainly three secondary products: clean water from one side, alternative biostimulant from the other side, and like third product, secondary raw material. So the approach of today, the first part of the presentation, will focus on the mainly activities developed, and after we will see the application of in a slaughterhouse to better show you the benefit in terms of environmental and economic aspects. So now I would like to leave the floor to Giuseppe Salvio from ENCO in order to have more information about the project.
Hello everyone. As Marco said, I'm Giuseppe Salvio from ENCO, and in this particular project we are managing the organization of each of those thematic workshops. Actually, this is the fifth one, and we are happy to have the opportunity to share with you this day. Let's start in this presentation. I will get you insights from a Water2REturn project in order to let you know what this is about, and then we will go more in details with Ms. Bortolozzo from 2B and Marco Della Feld. The first question that everyone made us is why Water2REturn? Because there is the need of resource recovery from wastewater effluents, and this is an issue that's it's particularly important in these phases of 2020. Then, because in the 21st century, agriculture has faced multiple challenges. So there is a growing of population of 9.1 billion, which is projected in 2015, with smaller rural. And then there is the food industry challenge, especially in the European slaughtering sector. This is characterized by high water and energy consumption, and especially the production of large amounts of waste and wastewater. And are you seeing my screen?
Yes.
Yes.
Okay.
Yes. But always the same slide.
Only the first slide, right?
Yes.
The slides are not in presentation mode now.
Is now visible?
Yeah, we can see the number 4, I think.
Yes. I think it now can be okay. Okay, so sorry for this small issue. As I was saying, the other issue that Water2REturn is focusing is the chemical fertilizer. This sector now is experiencing an unstoppable increase in demand, and their extensive use is problematic as they are associated with emissions of greenhouse gases, and this can cause an eutrophication if they leach into water bodies, among also other environmental problems. The current approach of treating slaughtering wastewater is another reason of Water2REturn, because in spite of all recognized benefits of adopting a circular economy approach, the current practice when Water2REturn project was written tends to nutrients removal instead of recovery and recycling, which is Water2REturn is doing. So that's where the main idea came from, because alternative and more sustainable approach are needed. So that's why Water2REturn is now a project, because it faces the environmental and economic constraints of the slaughtering industry as a market opportunity. Then it aims to adopt a circular economy approach to extract the maximum value from slaughterhouses effluents, and then it makes also possible, as I said also before, to recover nutrients from the slaughtering wastewater and turn them into valuable products. As we will see right after, we produce 2 biostimulants and 1 fertilizer. But what is Water2REturn? Water2REturn proposes an integrated solution for the slaughterhouses wastewater treatment, and as well for the recovery of nutrients with high market value in the agriculture sector. So this circular economy approach turns the wastewater treatment facilities into biorefineries. This is a project which is an innovation action, and is co-funded by the European Commission under the Horizon 2020 program. We started our journey in July of 2017, and soon, in the end of March, this will end. Is a consortium made of 15 partners from 8 countries. Here you can see the Water2REturn system. So we have a water line, which the main output will be secondary raw material number 1, which is a nitrates concentrate. This will be then worked, and we will obtain from it a first agronomic product, which is an organic fertilizer based on nitrates. Then we have a sludge line, which will produce another secondary raw material, which is an hydrolyzed sludge. And this will come on in a second agronomic product, which is a biostimulant based on bacillus biomass. The third one is a biostimulant based on algal biomass. And then we have also the energy line, which is connected to all the system. As I said before, from the first line, we will obtain a secondary raw material number 1, and then first agronomic product, which is a biofertilant. From the sludge line, we will obtain biostimulants. From the energy line, we will obtain the methane. All these 3 agronomic products, the important thing is that they are free of pathogens and heavy metal, and they are ready for the commercialization at the European and international level. Actually, we are going under the ETV verification, and all the agronomic products will be sustainable to be used both also, of course, in organic agriculture. The key innovation of Water2REturn are 3 basically.
Sorry, Salvio.
Yeah.
There is a comment in the chat, and he's right. We just can see a third of your slide. Maybe you should put the function key number 5 to have the whole picture. A little bit better now, yes. Just check and go ahead. This is great.
Okay.
And now take your 5th slide or what it was. Thank you. That's it. Looks good. We can see key innovations and results.
Yeah, that's the slide I was commenting on. So
thanks.
This is,
go ahead.
Thanks for telling me. This wastewater treatment. So we have 1 integrated treatment plus nutrients and the energy recovery system, and 3 separated process units, which I explained to you before, which are the water line, the sludge line, and the algae line, plus the energy recovery module. Then we will obtain, as I told you, secondary raw materials, and from that, 3 agronomic products. It will also make us create new business models, which are based on circular economy approaches. And these are also opportunities for all the involved sectors. So the wastewater treatment, the energy engineering and consulting companies, the manufacturers of fertilizer, biostimulants, and the slaughterhouses and all the meat industry. The Water2REturn demonstrator is based in Sevilla, and they have a treatment capacity of 50 meter cube per day, and actually they are at a TRL from 6 to 7. Here you can see pictures from the demonstrator. This is the entire system. And in particular, this is the water line. Here we can see the sludge line, the energy recovery module, and this is the pool, so the algae line.
Sorry, no picture.
Now it's visible?
So we can see the factory.
Now you should see the water line. I'm moving the slides.
Yes.
The slide line. Okay. Sorry again.
Yeah, I don't know why, because the system should handle it. But go ahead and Salvio. And there was another idea. Maybe the ones speaking, clicking on their camera, it's a bit nicer to be aware that you are with us. And I think today techniques doesn't take so much care if the camera is on. Okay, now we can see you and the slide. Go ahead.
We finished more or less, because this is the last section on advantages and challenges that we will be more analyzed in details right after. So the advantages are a new business model which are promoting industrial synergies. There is an environmental footprint reduction, so wastewater treatment and fertilizer and biostimulant manufacturing and use. There is the creation of business and green jobs. And the challenges that Water2REturn is facing are regarding the legal framework on wastewater reuse and bio-based fertilizer, the end user acceptance. That's why later on we will ask you to fill in the questionnaire that will take maximum from 4 to 6 minutes, and demonstrate the economic viability of Water2REturn system. The last part is the potential clients. Our potential clients are slaughterhouses industries, which are considered as early adopters, and of course also meat processing industry, disregarding more the part related for the wastewater treatment. Then of course, since we also produce 2 biostimulants and 1 fertilizer, our potential clients are also bio-agronomic products distributors, so all the agricultural sector. So we address conventional and organic farmers. Water2REturn, it's important to say that it's a modular system, so it doesn't have to be sold the entire solution, but they can be sold also singular module. So this can be tailored for future clients according to their needs and expectation. And another good point is that our system has an high replicability. So it's flexible system and it can be adapted to other food industries. So that's all from my side. Sorry for not showing correctly the presentation, and now I would like to leave the floor to Beatrice.
Okay, first of all, I would like, before to leave the floor to Beatrice, I would say that to all the participants, we will share the presentation so you can have all the presented material. From the other side, I would like to put the attention about the work, the workshop of today is to show you the results achieved during the project from one side, and from the other side is to understand from your point of view if you see this solution feasible from the technical point of view, and if you are interested to the entire solution or in a single module. So understand together which part of the solution is extremely feasible from your point of view, and understand together the next step to follow for the future.
Okay, I can start. Thanks a lot, everybody, for having me here. I'll try to share my screen, but you need to enable me, Marco. I need to be enabled to share the screen, otherwise I cannot do that. Marco, Giuseppe, can you?
Yes, let me check 1 second how to give you the permission.
I did, Marco.
Okay. Okay. Can you see my screen?
Perfect. Yes, it works.
Okay. I'm wondering now if I would do the full screen because we had some problems with Giuseppe. So if it is fine for you, I would keep it like that to avoid that there is a problem with scrolling down. And please let me know if there is any problem or if it freezes, it stuck. Okay, so today I would like to tell you about the sustainability assessments of this study. Of this project. I won't be able to give you a result, unfortunately, because of course results have been shared with the consortium, but I was able to visit the plant last week. I was there last week, which was really great after 2 years of not being able to go there. And of course, before giving all results outside of the consortium, we need them to be really top notch. So that is important for us. But I'm going to tell you everything that we have been doing for the sustainability assessment. First of all, who we are a sustainability consultancy based in Italy, nearby Venice, and we work on, in this beautiful, by the way, old silk factory from 1800, and we work on life cycle assessment, eco-design, eco-labels, and environmental communication and sustainability strategies for companies and universities and so forth. So we actually use 3 methodologies, and maybe some of you or maybe of you are already aware, they know these methodologies well, others maybe a little less. So we work on life cycle assessment to evaluate the environmental impact of products or services, on life cycle costing, to evaluate the economic impact, and on social SCA for the social impact. Why these 3? Because all these 3 together, they make the, they are the 3 pillars of sustainability: economic, environmental, and social. Okay, so life cycle assessment is actually the first-born methodology. It has been used now for quite some decades, from the early 70s. The first company that seems to have used life cycle assessment is Coca-Cola. Now many companies worldwide use it. Life cycle assessment is a methodology to assess the environmental impact of a product or service throughout its life cycle. So this means from the extraction of raw materials to production, packaging, transport, use, and end of life. So as this is very theoretical, I wanted to give you an example of what it really means in practice to do a life cycle assessment, and I would like to do that with an example of the life cycle of a milk bottle. Okay, and this has to do with cattle, so it's something which is not far from what you do. So what does it mean to do the life cycle assessment of a bottle of milk? Many think, okay, you start from the cow. Okay, well, actually it's more complex than that, because to do that, you start from the hay or the feed of the cow. And then you have to consider also the transport, which could be the boat, or the ship, or the track. And then you go to you get your farm, and then the processing of the milk. You need to consider the bottle. You need to consider the distribution, which is pretty peculiar with milk, because of course you need to keep the temperature at a certain level. So you need to have specific trucks, and then of course the fridge at the shop, the transport to your home. The use, in this case, the use is not taken into consideration, because I, for example, just take the milk out of the fridge and drink it like that, and another person makes a very elaborated recipe. So this is not taken into consideration. But you will have the end of life of the bottle. Is that it? Actually, this is not it, because you will have to consider also the whole life cycle of your hay or of your cattle feed. So you will have to consider the soil preparation, the seeds, the water that you use to grow your hay, and then, for example, the fertilizers or biostimulants that you use, and then the harvest, and then you will also have a packaging here, for example. And then you will consider, well, the cow, that's pretty an issue with the cow, because the cow is not only used for milk, but with the cow you can produce meat and you can produce leather. So all these impacts will have to be allocated in specific ways to the different products that are produced with your cow. And then, of course, the whole life cycle of your bottle, which is the production of your of glass. And then there you will also have a packaging, and you will also have a transport and end of life and so forth. And then also the production of your fridge, the whole life cycle of your fridge. Because, for example, in this fridge at the supermarket, we can say that this fridge contains in its life cycle 100,000 liters of milk, for example. So we'll have to consider the whole life cycle of my fridge, and then consider 100% of that impact, and use that for my bottle of milk, and so on and so on. So this means to do the life cycle assessment of a product or service. It is pretty elaborated. So for every single process, the processes that I showed you, you will need to consider all the inputs, so all the materials that go inside, the energy, the water that go inside, and then all the outputs. And then the outputs are emissions to air, to water, and to soil, the waste, and the byproducts. And then there you get the potential impacts, which are these ones. Like, well, one is now very high in the agenda in all the countries in the world, which is climate change. So carbon footprint is very important for companies, for countries, for governments, but then you also have many others of those. So to do the carbon footprint of a product, you need to do a life cycle assessment. And then one of the indicators is the carbon footprint. But then you have other indicators, like, for example, land use, water use, ozone depletion, eutrophication, acidification, and then you have those potential you have the potential damages on human health, resource depletion, and ecosystem quality. So this is pretty a work. So we have already seen that what are the indicators for the environmental life cycle assessment. For the life cycle costing, you get the cost. So you really have an economic analysis of your product or service. What is interesting is that you can combine life cycle assessment and life cycle costing, and you get the eco-efficiency. Why is this important? Because, for example, sometimes it is more expensive to produce something, but then on the long term, it pays back. So on the long term, it is better, or it is more efficient to have that product. It's more sustainable to have that product, which is more expensive than to have another. And then social SCA. Social SCA really considers the impacts to the stakeholders. And in the methodology that we have used, we considered the stakeholders considered that workers, local community, users, and small-scale entrepreneurs. So these are the three methodologies that we have used to analyze the Water2REturn project. Why are these methodologies used in general? Well, first of all, to improve a project or a product or a process for eco-design purposes. The very first reason why life cycle assessment has been developed was really for eco-design. How to do something from scratch which has a reduced impact, to set priorities, because all companies have a limited resources, limited amount of money. So where should I look for better solutions where the impacts are the biggest? If an impact is very small, maybe I'm not going to waste my time on looking for better solutions on that. For communication, because greenwashing is something which is even pursued now by different governments and countries, which is very fair. So life cycle assessment and life cycle costing, social SCA gives you a way to make communication which is transparent. It's based on scientific approach. and then to make comparison. Which process is better? Which material is better? This is very important. It also helps to reach the Sustainable Development Goals and develop strategies, because I can measure my situation this year, and then I set some goals, and then I remeasure the situation next year and see if that is improving, if that is the right way ahead. So for Water2REturn, this is exactly what we did. On the left side, you see the picture of the Matadero del Sur, which is the slaughterhouse in Spain, close to Seville, before Water2REturn. And then on the right side, you see Water2REturn methodology. So what we did is that we applied the 3 methodologies to the situation before Water2REturn, and then also the whole methodology. And we also considered both the construction and the operations. And we also considered 2 other things. The demonstrator, as Giuseppe says, has a capacity of 50 cubic meters per day of wastewater treatment. But this is a demonstrator. So what we also wanted to see was if in a real scenario, what the impact would be. So we also calculated a scenario of 150 cubic meters of wastewater treated, because it was more realistic. And as you saw, maybe you remember when I was telling about, life cycle costing, doesn't mean that if you improve the quantity, maybe there are some advantages there. So this was also very important to check. What we also analyzed is the production of the biostimulants, because this is also part of the project. So this was included in the analysis. So we have, from this project, we have 2 biostimulants, and actually the fertilizers hasn't really been produced, which is fine. I mean, this is part of research. When you research, some things turn out to be perfect, and other turns out to be a bit different. So what happened is that the water that comes out from this from this slaughterhouse is not as rich in nitrogen as expected. So the formulation of the fertilizer is not commercially viable. But, which is something very interesting, is that this water that contains nitrogen but not high enough to make it a fertilizer can be directly used to fertilize the land around the slaughterhouse. Okay, so all that has been taken into consideration. This is, for the environmental assessment, really the flow chart that where you have all the different pieces of the 4 lines that have been considered. So the water line, the sludge line, the energy line, the algae line, and all the connections with raw materials, energy, water, and emissions. So it's pretty complicated. And within these, all these little squares have been filled with a lot of data, and the calculations have been made. For the social part, we have studied literature, we have discussed with the consortium, and we have come up with these indicators, and these indicators then have been analyzed both on the quantitative point of view and the qualitative point of view. So for the workers, we considered health and safety, remuneration, discrimination, freedom of association and collective bargaining, and work-life balance. For the local community, we considered health and safety, access to material and immaterial resources, community engagement, skill development and contribution to economic development. And for the users, health and safety. By users here, we mean only the farmers, so it's less interesting for you, because the users that use the biostimulants, okay? So that is what it is. So as I told you, we did both a quantitative assessment but also a qualitative one for social SCA. Why is that? Because, for example, for discrimination, it is very difficult to quantify, to give a value to discrimination. While, for example, you can say this is the amount of CO2 emissions that they have. It's 10, it's 100, it's 1,000. With discrimination, it's a bit more difficult. I wanted to show you an example of the database that we use, which is one of the most famous databases for social life cycle assessment. It's called Social Hotspot Database. This is not the situation of the project, but I just wanted to show you this is the before I tell you that, is when I buy any product in one country, this has repercussions in many other countries. If I buy this shirt, it's made of cotton, and I buy it in Belgium or I buy it in Italy, this will have consequences, social consequences very far from me, for example, in Asia where the cotton is grown, okay? So this is exactly what this slide shows you. So this is the risk of child labor for beef production worldwide. Okay, so if I buy beef from India, that is the risk that a child has been used to produce meat there. So the countries in dark red are the countries where the risk of child labor is very high. Those in red is where the risk is high. Then orange means medium risk. Low means, green means low risk, and blue is where there is no evidence. Okay, no evidence of any risk, and then gray is where there is no data. But this is interesting. So we have used all the data that we have collected for the baseline and Water2REturn project to fill into this database and get the consequences in the country involved, but also down the line. And what we have as a small anticipation here is that the major issues are health and safety. This is the baseline. So for a slaughterhouse, let's say, health and safety, labor rights and decent work, governance, and then community and human rights. This does not mean that this happens in Europe, in this case in Spain, but this is down the line what happens through the supply chain, let's say, also in other countries. But of course, we can go deeper and then analyze where these potential impacts actually happen in what country. So this has been done. To summarize, is that the wastewater treatment of slaughterhouses is a concrete issue. Okay, so this needs to be dealt with, and projects like this give future vision and innovative visions, which is really great. So what happens is in this project is that nutrients from wastewater are recovered, and then they're turned into biostimulants, which is great. And what is the big thing here? Not only that you produce a biostimulant, but also, and which is what we considered in this project, is the avoided production of other virgin raw materials that you would need to make those same biostimulants. Okay, so this is a double advantage. So with this methodology, you are able to evaluate the potential impacts, but also the advantages of new technology, and this is what has been done. Thank you for your attention, and I wish you a good continuation of this meeting.
Beatrice, thanks a lot.
Now I need to stop sharing.
Yes.
And I need to see how this, I actually don't know how this can be done. Have I stopped sharing?
I think so.
Okay.
Okay. Okay, before to move to the next presentation, I would like to, okay, there is a question from Brigitte Kaiser that asks, when will the results be published?
You mean for the sustainability results? These results, well, next month, absolutely, because at the end of the project is going to end at the end of March. So at the end of March, everything will be available. Yeah.
In any case, to read all the public deliverable and the study achieved during the project development, you can follow us on water2return.eu, where you can be always updated about the project results. Is there another specific question related to the life cycle assessment?
Marco, maybe you can put the address in the chat, then it's easier. We are already nearly 50 people, so that could attract them to join that, and then there is no spelling mistake.
Done. You can find in chat, but in any case, I repeat, at the end of the meeting, we will send to all of you all the registered participant the presentation of the other materials. So in case you are not registered, please write your email and name in chat, so it will be easier for us to share with you all the material. I hope that you can see my screen now. Okay, seems yes. Now, my presentation is mainly focused on the meat market overview and benefit of using the water-to-return solution. In particular, like I have already said before, it is extremely important that the developed solution is in line with the specific market needs. The European Commission founding a project that will be useful for the market. And this is the reason why UCBB is one of the partner of this project in order to put in contact the meat industry with the technician and the researcher. One of the main results of the European project in general and of Water2Return is to bring a reasonable solution on the market that support the slaughterhouses to reduce the water consumption and to adopt an innovative business model for this kind of innovative solution. So my main presentation will be focused from one side on an overview of the meat market. I will be faster and faster because maybe you know the meat market better than me. And from the other side, we will try to go more in deep to understand how concretely the water-to-return solution could be a support for the slaughterhouses. So we try to have a meat market overview at the global and European level. The slaughterhouses legislative framework. We will go more in detail in the Matadero del Sur demo site, and we will see together the environmental and economic benefit of using water-to-return solution. So in the last year, the global market and in particular the meat industry value at worldwide level, if we compare 2020-2022, is increasing, and forecasts for 2025 are see another increasement of this value. So for sure is an important market that are growing year by year. And this is the reason why we have tried to develop a solution that is useful for the meat market. Here you can see the distribution of the meat market worldwide in 2020 by region. And we have divided in North America that cover more or less the 20%, the Asia Pacific countries that are around 49%, and the rest of the world that cover the 31% of this market. If we go in terms of revenues of the meat products and the sausages market worldwide by country in 2021, we see that the leader are United States. The second country is Germany, and after we have the Russia. One of the most useful results of water-to-return solution is to increase the revenue coming from this industry. In particular, the approach in the business model is to reduce the cost from water treatment and increase the revenue selling secondary raw material coming from this solution. This is the really added value of the water-to-return solution, because the slaughterhouses from one side can reduce the cost for wastewater treatment following the actual legislation, and for the other side they can increase the revenue coming from the secondary raw material. So we're trying, following the circular economy approach, to transform the wastewater that today is a waste and represents a cost with the revenue. This is the most important approach and philosophy of the solution developed during our project. If we see the production of meat at worldwide level from 2026 to 2020, we see that more or less the million metric tons are more or less the same after an interesting growth between 2016 and 2017. And here we see the different type of products. We have pork, poultry, beef, and sheep. Also, the per capita consumption of meat worldwide between 2018 and 2020 see the Europe like third market after North America and Oceania. So Europe play an important role in this scenario, and this is also the reason why European Commission support us with this project due to the importance of Europe in the meat industry. If we see the forecast for per capita meat consumption at worldwide level between 2021 and 2030 in kilograms for per capita, I repeat, also in this case we can see a growth for the next year. However, if we see the same forecast for the European market, we need to register a very slow reduction of meat consumption, also due to the campaign done at European level. By the way, we remain, in terms of per capita consumption, an important market for the meat industry. Here we have focused the attention for the different nations, and we can see that the leader in terms of consumption is Germany, followed by Poland and Italy. This is a picture made in 2021 with, of course, forecast for 2022. And also in this case, we have done an analysis of the different products. So we have here a graph with per capita consumption in 2032 divided in beef, pork, poultry, and lamb. So after this overview on the meat industry, in this slide you can see why we have focused our attention and developed an innovative solution for the meat industry. Because you can see the percent of edible meat for human consumption for the different categories. And you can see that in the poultry production, we have the 68% of edible meat. In pig production, we have the 62. In bovine, we have 54, and in sheep goats, we have the 52, with a significant percent of inedible meat. So breeding livestock translate into generation of waste. However, it's during the slaughterhousing process that most organic solid waste is produced. The amount of solid animal waste will change according to the type of animal slaughterhouses. And this is the reason why the solution has been developed for slaughterhouses. Furthermore, in spite of the actual filtration system in place, solid wastewater still contain a very high amount of organic and inorganic suspended solid and soluble particles, very high concentration of nutrients. So, like we have already seen in two past presentations, we transform wastewater into nutrition and nutrients products. We also need to take into account the regulatory aspect. On the left, you can see the regulatory aspect focus on the fertilizer. On the right column, you can see the most interesting regulatory aspect for us that cover aspects related with the Water Framework Directive, SLOW Directive of 2020, and EU Biodiversity Strategy for 2023. Like we ever say, we will focus our attention on the last three elements. So regarding the Water Framework Directive, the Water Framework Directive is an EU directive which consists European member states to achieve good quality and quantitative status of all water bodies. This directive stipulates the groundwater must achieve a good quality status and good chemical status. And in 2009, the Court of Auditors has published a special report on wastewater treatment, urban wastewater, and sewage load. The document is being consulted and modified to reflect the best standard, and with our project, we try to follow all these directives. So we can say that if we have environmental benefit, we are also sure to follow the right directive. About the sewage load directive, it has been written 30 years ago in 1986. The proposal is to regulate the use of sewage load in agriculture in such a way as to prevent harmful effect of soil, vegetation, animal, and human. In 2020, directive has been written with both the needs of the environmental as well as the needs of farmer in mind, and over 65 organizations have given feedback. The experts on Water2REturn have reviewed the latest directive and feel positively and as its rules and restrictions line up with our system. The third is the EU Biodiversity Strategy for 2030. Is a comprehensive ambition, a long-term plan to protect nature and reverse of degradation of ecosystem. Is connected with the Green Deal, the Farm to Fork strategy defined by the European Commission. While not linked directly with our project, it shares many of the core goals like reducing the use and risk of pesticides by at least 50%, increase the use of organic fertilizer, and restoring degraded ecosystem. So with our solution, for sure, we are following all the latest directive defined by the European Commission. Of course, there is an upcoming regulation on different technologies that it shall apply from the 26th June 2023 and cover the secondary treatment, filtration and disinfection in order to reduce water and define new standards for cleaning water. Regarding the actual situation, the current approach for treating slaughterhouses wastewater, in spite of all recognized benefit of adopting a circular economy approach, current practices tend to nutrients removal instead of recovery and recycling. We have developed a new approach and an alternative solution that face the environmental and the economic constraints of the slaughterhousing industry and market opportunity. It aims to adopt a circular economy approach to extract the maximum value from slaughterhouses effluents. It makes possible to recover nutrients for slaughterhousing wastewater and turn them into value products for the agricultural sector. We have already seen some information about the demo sites at Matadero del Sur, that is slaughterhouses in Andalusia, and where we have developed our demo sites. This is interesting a picture from the satellite that show you that this solution needs space in order to have the water recovery. An area of more than 80,000 square meters, 3 slaughterhouses lines, cattle, pigs and sheep goats, cutting and packaging room, a sausage factory and a slicing plant. So we are trying to cover all the different, most of the different industry line in slaughterhouses. We have a 50 cubic meter per day, and you can see the different line that has been developed. So the benefit, we have a wastewater treatment with an integrated system to treat wastewater while recovering nutrients with a novel combination of technology and process that maximize the extraction of the valuable products. We have raw material and extraction from slaughterhouses with 3 different raw materials for the agronomic products, and in particular nitrate, phosphate concentrate, and algae biomass, and 3 produced agronomic products, 1 organic fertilizer and 2 biostimulants. Also, we have our solution makes other fertilizer cheaper, add more fertilizer and bioproducts to the market, and in line with the existing legislation, so fulfill the increasing restrictive legislation on the agronomic products and come from an EU project, so we are in line with the future, or we have tried to be in line with the future. Regarding the environmental benefit, we have a reduction of wastewater of around 90% and reduction in waste delivered to landfill around the 80%. In terms of recovery rates, freshwater saving is around between 20 and 40 in the meat industry, and we have up to the 95% of nutrients recovered. The economic benefit that maybe is the most interesting part. Regarding the treating cost, with the conventional solution, we have an average cost of 2.63 euro for cubic meter of wastewater. With our solution, we decrease this cost around 30% with the final cost of 1.85 euro for cubic meter. Regarding the business opportunity for the involved sector, we have a wastewater treatment for sure, energy engineer and consultant company, fertilizer and biostimulants industry, and the meat industry, of course. In the last 2 months of our project, we are also developing a business plan and a business case that will be published on our website, where you can see the entire cost plan to understand better the needed investment and time of the return of investment. It means that if I invest an amount today, I need to know after how many years I will back up this investment. We have already seen about the potential clients, taking also in consideration that we are speaking of a modular solution, and that's it from my side. So now I will be more than happy to receive a question, specific question from your side, in order to understand what do you think about this solution, and if you see this solution in the future of the meat industry. Is the reuse in the process of water after treatment investigate of the project? Christophe, good afternoon. I'm trying to reply to your question in case maybe you can open your microphone and we will discuss together. The reuse of water is a part of the process of water-to-return. So it's mean that the clean water will be used internally with a closed loop in order to reduce the consumption of fresh water. So everything from our system come clean water, and it used for no sanitary aspects in the slaughterhouses.
Okay, thank you, Marco, because it is a key point for us to reuse the water after treatment in slaughterhouses. I'm working for French slaughterhouses, but as I can know is that the cost is very high to make the water usable in contact with food. So that's why I am interested by the figure you presented according to the cost. But so that includes the treatment of water, of wastewater, for a new use in the slaughterhouses process, right?
In the slaughterhouse, inside the slaughterhouse, yes, but not in contact with food, because we don't have reached the quality certification. That is another important aspect, the certification of the water. And thanks a lot for your question. But at the moment, we haven't reached this authorization. I would like to add something. There is an indicator that tells us how a solution is ready for the market, and it's called technology readiness level. Starting from 1, that is just an idea, up to 9, that is when the product is ready for the market. With our solution, we have reached a TRL 7. It means that we are quite close to the market, that we have tested our solution on a real industry, but we have just done a demo site, and there is a corrective action that we need to put to develop and put in the field of application. And this is an activity that it will be done in the next 2 years in order to be ready at the end of 2023 with the commercialization of our solution. It means that the technical partner will be ready to sell this solution with a general contractor in order to go there, make an as-is situation develop the project and install the system, taking, of course, taking into account the specific needs of each slaughterhouse.
Okay, thank you.
There is another question from Mika. How is the acceptance fertilizing regulation of waste water delivery fertilizer in the EU? If this kind of component material is considered to belong to CMC 11 animal byproducts and are still tied by the products directive which prohibit to this use. Okay, in terms of acceptance, seems that the new regulation also the secondary raw material, and Mika, in case we want to open a discussion, please turn on your microphone and we speak together, the secondary raw material products, and in particular the fertilizer, are in line with the actual regulation. So we don't see particular problem to the commercialization of these secondary raw material products. Of course, also in this case, in our consortium, we have a fertilizer company that are in charge of the commercialization of this secondary raw material. Now, if there are no specific questions about the presentation, I would like to receive feedback from your side about this kind of solution. You are more focused on the meat industry, on the slaughterhouses. So do you think that solutions similar to this could be in the future of this market sector? This solution is in line to solve a specific problem of the slaughterhouses. What is your feedback? What is your sensation? Do you think that wastewater treatment today is a problem for this industry? It will be extremely useful for us know your point of view. Okay, there is another question. I have analytical results of treated water. What are the results of the total nitrogen and total phosphorus? And the crucial aspect, AU end of waste criteria, which has not really progressed at all. Okay. Sonia, I'm trying to, okay, we have some analytical results coming from desk analysis. So the theoretical KPI and results have been calculated. Now we are in the phase testing in Matadero del Sur to understand if the results obtained during the desktop analysis are in line with the realistic analysis. So at the moment, we don't have an analytic results in terms of quantity. By the way, it seems that due to the value of this secondary raw material and the value of the wastewater treatment today, the solution is economic, is feasible from the economic point of view with a return of investment between 4 and 5 years. depends from the size of the slaughterhouse and other particular parameters. But it means that an investment is being paid in 5 years that is perfectly aligned with the market parameter. Mika, again, EU end of waste criteria, which has not really progressed well. Okay, Mika, can you explain me a little bit better?
That my comment was really about the fact that EU has strong hopes of progressing nutrient circulation and circulatory systems, but has lots of legal reasons why we can't proceed. Among them is that when the waste is not anymore waste and can be used as ordinary material. And that we see in many places, not only in wastewater. So there are only a handful of materials that have received this at an EU level end of waste criteria. This means glass and certain metals. But anything else is to be left for country by country decisions.
Yeah, I agree with you that this is a crucial aspect, and at the moment not at the moment, with our project we have not managed this aspect related with end of waste. This is a part that needs to be covered and needs to be better understood. And maybe in the next year we will work on it. There is another question from Brigitte. Nutrients in wastewater from slaughterhouses will be regulated in the upcoming BAT conclusion for slaughterhouses under the Industrial Emission Directive. Have you looked at that? Yes, we have taken a look, of course, of this new regulation, and the parameters of our solution are in line with these new regulatory aspects. Of course, also in this case, we are still waiting for the results coming from the demo sites in order to receive a certification of the work done. Okay, there is another question from Christophe. Are the nutrients extracted from the water enough dry to be exported far? Yes, at the end of the process, the nutrients are dry and they are ready for the commercialization in everywhere. So we don't have a particular problem related with the final user of these nutrients. And there is, I repeat, one of the partners is extremely strong in this in all the aspects related with the nutrients, and we have worked with him to better understand how to move and transport these nutrients. Luke, don't worry, we will please send right here your email and the email of your colleague, and also with you we will share all the presentation.
Great, thank you very much.
Together with the final email, we will also send to you a questionnaire, because we have developed an online survey. It takes just 5 minutes in order to understand the specific market needs, and for sure your support filling this survey is extremely important to understand if all the needs have been covered by this project, or there is something that we need to do in the next year. So, of course, you will receive the presentation and also the link to this survey, and I kindly ask you to fill this survey. Other comments? Do you think that this technology could be useful for the future of the slaughterhouses and the meat industry in general? Okay, so if there are no other particular answer, Carsten, I think that we can also, I don't know if you want to summarize a little bit the outputs of this interesting workshop from our side.
I'm for sure not able to summarize and wrap up. That's what where the contribution done by you. Thanks a lot, of course, and the organization like with Salvio, sorry, and Beatrice as well. So, as I said in the beginning, when we started with about 40 people, in the end we were nearly 50. Sorry, showing interest. And as 20 already left, now I'm not sure if this is an expression of extremely much appreciated input and value, but for sure it showed interest. So as Marco said, there will be a follow-up first, of course, of sharing all the presentation, and the colleagues from Ireland already asking for that, and be sure it will be sent immediately. Second, this questionnaire Marco was referring, and third, just to recommend and ask back. Don't hesitate to send your questions or additional ones or specific ones. And Marco, maybe give a last sentence of the next steps foreseen as this is coming to an end. There will be a report, there will be a workshop in the end with the commission services. Maybe that's to you, and
Yes.
thanks to the colleagues. Ending here, saying thanks, handing over for the last word. Thank you, all of the participants and the ones preparing this workshop.
Yes, Carsten, just to close the workshop, first of all, thanks to all of you. In March, there will be visit to the demo sites in case some of you will be interested. Please let me know. In any case, on our website, all the final report will be published. In case you have questions, you have doubts, or you want to open a discussion, I repeat, we remain with all our contacts at your complete disposal, because the discussion with the possible end user and the technician is extremely important, not only for this project, but in general for the future. So in the recap email that I will send just this afternoon, I kindly ask to back in contact with us and to share this information and this presentation to trying to develop a feasible solution for the future. So thanks a lot to all of you, and in case, I repeat, we remain at your complete disposal.
So thanks a lot, and see you and the rest via written procedure. Hopefully, Marco, we have all the mail address, all the colleagues have to forward. Thanks so much. Have
Thanks
a
to
nice rest of the day.
a great
And
pleasure.
stay safe.
Thank you very much.
Thank you very